We have the Toll Club International. This is a social organization for women. It's called the Toll Clubs International. The requirement that women must be, the woman height must be at least 70 inches to join the Toll Club International for Women. Given that women have normal distribution, we say women's height is normally distributed with the mean. The average for women's height is 63.8. 5 feet 3.8 inches, almost 5'4", with the standard deviation sigma equals 2.6 inches. Find the percentage of women who satisfy the height requirement. It says if you want to join us, you're going to have a height of at least 70. At least 70 inches. Knowing that women's height is normal distribution. So the problem is telling us the height of women is actually normally distributed. It's mentioned that. You'll see that in the problem. It's normally distributed with the height being the average being this and the standard deviation being that. So the word normally distributed is given to you. You'll see that in all these problems. So now, first step is graph it and trying to decide if it's the left side or the right side. Women's height is normally distributed. There's the mean and the standard deviation right in the middle there. There's the mean, 63.8. Let me write the standard deviation under it, which is what? 2.6. It says if you want to join us, you got to have a height of at least 70 inches. At least 70. What does that mean, at least 70? That's the minimum value, so 70 or more. So if this is the 70, to join them, you got to be in this group, 70 or higher. And what percent of the women belong or can join the Toll Club International? What percent? When you say what percent, what is the probability? Which means the first step is I got to find the z value. Z equals x minus mu divided by sigma. X is 70. Mu is what? 63.8. And sigma is what? 2.6. And it's always you want to make sure the z value is in 2 digits, 2 decimal places. I shouldn't say 2 digits, 2 decimal places. So 2 decimal places, that number becomes what? 2.38. Always 2 decimal places. Why? Because when you go to the table to look for that, you need 2 decimal places. 1 for the left side, 1 on the top. So now the probability that the height will be at least 70. We need to know what is the size, what's this area to the right of the 70. Now, if I go and I look at my standard normal distribution, if I look at the 2.38, that's the z value, and I'm looking for this value, but if I look at the 2.38, it's going to give me which number? The one to the left. Remember, the table we have for you is always the area to the left of that. So it's 1 minus, and let's look and see what is the area to the left. So I got my chart still on the screen. Let me switch here to it. Did I close it? Don't tell me I closed it. Darn it. I did close that one. So what do you got, Jamie, on, I mean, not sorry, Jamie, Mark, what do you got on yours? It says 2.38. Or Jamie, if you have yours, that's fine too. So look at 2.3 on the left and 8 on the top.
0.9913.
0.9913. Make sure you are using the positive z-score. So 1 minus that number, which is what? What percent? Here we go. So this is the probability as a percentage. Move the decimal point how many places? 2 places. So less than 1% of the people, actually, women, can join the Toll Club, International Women Club there. Less than 1%. Let's try another one, another example. Maybe this is not a good one to be talking about today or this week, period. Airline flight crew requirement. Airline flight crew. Now, if you decide to join the Air Force to be a pilot, there is actually a minimum and maximum height for you, because those aircraft, the military ones, the F-15, F-16, a small area. So if you're really like a tall person like Shaquille O'Neal, you're not going to fit inside that. They can't close that glass on you unless they make it topless plane there and fly with no cover there. And if you're a small person, you can't reach the pedal. So if it's too short, you can't be a pilot. If it's too long, you can't be a pilot.
Just wear heels.
Well, we'll see here. It says British. Now this is a British airline, actually. This is commercial company. British Airways and many other airlines have a requirement that a member of the cabin crew must have a height between. So the height must be between. This is British airline. And other airlines are saying they use it, probably American airline, who knows. Height between 62 inches and 73 inches. So that's between 5'2" and 6'3", or 6'1", I'm sorry, 6'1". Given that men have, notice again, normal distribution height, normally distributed height. Men here, we're talking about. Again, they're bringing men here instead of women because that means more women can fly it there. 5'2", well, that eliminates actually a lot of people. There's some people, a lot of people, especially women, less than 5'2". You know. The average height based on that normal distribution with the average height for men is 69.5 inches. And the standard deviation is 2.4 for men. Find the percentage of men who satisfy the height requirement. Okay. What percent of the men actually satisfy this requirement if they want to be a commercial pilot? This is the average, 69.5 right here. Sigma is 2.4. To be a commercial pilot, you have to be between the 73, this is the 73 right here, and the other one is what? 62. So what percent of the people between these two heights. That's what we're looking for. Between 73 and 62. That means I got to find the z value that goes with each one. Let me find the z value for the 73, the z value for the 62, and do the problem. So z equals x minus mu over sigma. Let's try the 73. That's 73 minus what? 69.5 divided by 2.4. 73 minus 69.5 equals divided by 2.4. 1.458. So it has to be two decimal places, 1.46. And let's find the z value for the 62. Minus 69.5 divided by 2.4. Negative 3.125, negative 3.13, two decimal places. So we found the z value for each one, and now we need to find what percent of the people fit that. So the question, what is the probability that a person can be between these two heights? Has to be bigger than negative 3.13 and less than 1.46. Now go to your positive z-score and look for z equals 1.46. Excuse me. Thank you. And give me the answer to that. What is the area? And that's to the left of this number. That's from the 1.46 all the way to negative infinity, all the way down. And that will give me what? 0.9279. Good. Let's look for the area to the left of negative 3.13. That's the negative z-score. .0009, and now we subtract them. Why do we subtract them? Because if you look at the first number I gave you, the first number is really to the left of 1.46. That's all the way down, like this. That's what the first number. I don't want to go all the way there. The second number I just gave you is this area. So what happened if you take the first one, the red one, take away from it the blue one, you end up with that area. So that's what? 0.9270. And if you want to change that to a percent, says what percent of the people fit the airline requirement? It is actually 92.7% of the people fit that requirement. Okay. Let's look at this problem. This is backward. This is about actually colleges and students. And the problem states some educators, that's like STCC, UMass, Harvard, MIT, all these schools, argue that all students are served better if they are separated into groups according to their ability. So instead of putting everyone in the class, giving you guys tests and see what your IQ is, and if you're in the bottom half, put all the people in this class with the bottom half IQ, put the other people in the class with the one with the high IQ in a separate class together. So they believe here, assume that students are separated into a group with IQ, so we have 3 groups. They want to separate them. So if we take the students, separate them, we want the lower IQ, 30% of the people with lower IQ to be here. Leave 40% of these people here. IQ is between these numbers, and the upper 30%. So when you go, if you're in this class and you go to that class, everyone in that class has an IQ in the top 30%. If you're in this group here, everyone in the class should have an IQ in that range between these 2 numbers. I'm going to show what these numbers are. And if you are like lower IQ, you'll be with this group. So they want the bottom 30, the middle 40%, and the top 30. That's what they believe, if we do them that way. Now, the adult intelligence scale yield, that IQ score obtained through a test, and this has actually been monitored closely lately, IQ scores are normally distributed. It tells you it has a bell shape, with the mean equals 100, and the standard deviation for all these students is 15. Find the values that will separate the bottom 30, the middle 40, and the top 30. Find what these values are, what these scores are. So for example, if you scored 76 on the IQ test, do you belong in the bottom 30 or in this group? We're not sure right now. We have no idea. If you got a 79 on the test, are you here, here, or here? If you got an 84, where do you belong? So we need to know what these numbers are. Let me find this number first, the low one. Let's focus on this one. I want to find this one. Let's call it X for now. When you look at that picture, that number actually, just study that number alone, it says this number is going to separate my list into what? The 30% here, which means to the right of that number will be what percent? How about 70? Right? This number is the bottom 30%. Anyone over that, I don't say which group, but anyone over that is the 70%. So now we're going to work this problem backward. This is the X1 here. Let's change it to probability. If this is the 30%, that's 0.0, 30 divided by 100, what is that, 30? 0.3000. That's the size of that area. Can we find what the Z value is? You know how we normally have the table, we get the Z score on the left, we have the second decimal digit on the top here, and we give you these numbers, you look for them. Here we're going to work back and look inside the table. See the closest number to 0.3000. Mark, I'll take yours now again.
Don't you want negative 0.300 in that case?
Well, it's going to be the negative Z score. The area will never be negative. Mark's saying, doesn't the area have to be negative? I said, no, the area will never be negative.
Oh, I
So,
thought that's what you were.
so since the line here, this is z equals to 0, I know I should be looking at the negative z-score. But if by mistake you start looking at the positive z-score, go ahead, look as much as you want to. You will never find a number close to 0.3000 here. You grab the negative z-score, you start looking. You're going to look inside the table, find the closest number to 3000. I saw one close enough. 3000. What is it? Right, I see 301. You see a number less than 301? Or closer than 301? Let's look at negative 1.88. That number. That's 03. I want what? 0.30, I'm sorry, 0.3000. My mistake. 3000. Where is it? 3? I have 0.2981 and I have 0.3015. Which one's closer? 2981 or 3015 to 3,000 or 300, whatever, 3,000?
3015.
3015. So that value for that is negative what? 0.52. That's the closest number to 0.3000. Negative 0.52. So negative 0.52 is equal to the x value minus mu over sigma. Oh, x, not 100. X minus 100 divided by the 15. And if you do the math, you have a 92.2. So a 92, actually, we'll use a whole number. A 92, that'll be this value. If you score below 92, you're in the bottom 30%. Let's see what that number is. We'll call it y. If you look at y now, I don't care about x. This is y. The area to the left of that will be what? 70%? Because I'm talking from here all the way to infinity. That's 0.7000. If you change it to a z value. So the z value for that is going to be 0.7. Let's look inside the chart, but now I got to use positive z-score. 0.7000. 0.7. It looks like the closest number, 0.52. 6985. 0.52. .52 is equal to what? X minus 100 over 15. Can we solve for x? It's 107.8, which is what? 108. So if your score below that 92 or lower, and 108 here. So if you scored below the 92, you're in the bottom 30%. Between the 92 and the 108, you're in the middle 40. Over the 108, you're in the top 30%. What score is considered unusual here?
Anything,
Go ahead.
anything above 108?
Nope. What score is considered unusual? If we give a test to somebody, and what value is considered like, I hate the word retardation, so it's a mentally challenged. What score, if you score below that, you are considered mentally challenged, and if you score above that, we go close to a genius.
Above 123 for upper, because you go one standard deviation above 108.
No,
No?
Is it two?
no. Unusual. Yep. It's 2 standard deviation, right? Yep. So we expect most people, we expect 95% of the people taking this test is within 2 standard deviation. Mu plus 2 sigma, mu minus 2 sigma. So we expect this one is what, 130? And this is 70. 95% of the people in the world taking this test should score between these two numbers. That means there's 2.5% of the people going to score below that 70, and only 2.5% of the people is going to score above the 130. So when somebody scores above 130 or higher, go, oh, he's a genius. And that's really like the cutoff number. When somebody scores below 70, we go, that person needs some help. You know? But if you're between the other two numbers, that's where we expect a lot of people to be. If you toward this end of it, you're going to, let's say in a class like this where the students all put together, you will struggle. But if you toward that end, you're going to be one of the smartest one in the class. Every once in a while, we got somebody in the class who's in this group right here, and every time we give a test, that person gets 100, and everyone else gets a 50, or 60, or 70. Because he was right there. Not many people are going to be in this range. Not many people are going to be in that range. So 2 standard deviation, that gives you 95%. Anyone outside that is considered unusual.
Just to clarify, that's not U plus 26, right? That's
U plus 2
standard
sigma.
deviation.
Yeah, correct. Let's take another couple more examples here. Let me see if I can find some interesting topic beside IQ scores. Okay.
Ooh, you could do ages for car accidents. That's always interesting, seeing like the number of car accidents that happen between certain ages.
Well, I was looking at Disney characters. Figured that would be cool.
Disney characters.
Water taxi. That's another one. We can look at it. Length of a pregnancy. You guys don't want to know anything about it.
No, it's normally
Well, you know what? Actually, this might be interesting. Cool here. For pregnancy. It's not just about the pregnancy. Because we have to deal with planning in advance. What I mean by planning, when you're building a hospital, you have to know what percent of the people are born premature. You got to make sure you have the equipment waiting and ready for them. So let's take that one. So hopefully you guys have no idea how long a pregnancy is, which is good. That means you're clueless on it. You know, but I'll give you a little lesson on that. Length of pregnancy. Now, length of a pregnancy are normally distributed, so you're always going to see that. Anyone knows how long the pregnancy is? How many months? Very good. So you have an idea. It's 9 months. Has actually a mean of 268 days. If you take 9 months, an average of 30 days per month, what's 9 times 30? 270. So this one says, based on the record we studied there, pregnancy average is 268 days, which is almost 9 months. You're 2 days off the 9 months. It's usually within 2 weeks, give and take 2 weeks once the baby's ready. Standard deviation sigma is 15. That's the 2 weeks. So we're saying pregnancy is normal distribution with the average being this and the standard deviation being that. This actually was in Dear Abby. True story, Dear Abby. One classical use of normal distribution is inspired by a letter to Dear Abby, in which a wife claimed to have given birth 308 days after a brief visit from her husband, who was serving in the Navy. And the question, given the information, find the probability of a pregnancy lasting 308 days or longer. What does the result suggest? Blood test. That's what I recommend. So this sailor comes home.
That it's the father.
Well, actually, you'll be surprised. It's not as small as you might think. This sailor comes home, visit his family, and his wife, he leaves, and she doesn't see him for a while, still serving, let's say in Iraq. But after 308 days, his wife gave birth. 308 days. And the question, what percent of the pregnancies last 308 days or longer? So that was in Dear Abby. What percent of the pregnancies will last 308 days? Or longer? Because that's what they're asking. What percent of, there we go. Where is it? Find the probability of a pregnancy lasting 308 days or longer. 308 days or longer, that means larger than that number. To the right of that. So I got to find the z value first. Z equals what? X minus mu over sigma. Remember, if it's more than 2 standard deviation, that's really unusual. There's going to be more than 2 standard deviation. (308) minus 268 divided by the 15, it's 2.67. So it is unusual. It's outside that range of 2 standard deviation. So now we know what the z value is, and this is now the z-score, which is 2.67. And we're looking for that area, to the right of that. What is the probability that the value will be greater than 2.67? Now remember, this is a positive z-score. If I go to the positive z-score here of 2.67, it's going to give me the area to the left. So it's going to be 1 minus the number to the left. What is the number to the left? 2.67. 2.67. 0.9963. So if you do the math, .0038. When you think about that, and I say it's not really that rare, it's 38 people out of 10,000. So every 10,000 pregnancy there is, actually 38 of them will last that number or higher. Or approximately 4 out of 1,000. For every 1,000 deliveries, 4 of them will last approximately that date or longer. The probability is very small. Percentage-wise is what? 0.38%, so it's not a high percentage. That suggests it's unusual. It's kind of rare, almost less than 1%. It's very unusual. Because the question, what does the result suggest? Now let's continue with this. There's another part to this problem. Pregnancy is 268. This is 15 days. Part B now, using this information, let's talk about babies are born premature. This is very common. Baby is premature if it fits this criteria. Is in the lowest 3%. Find the length. Find the length. That means how many days, not how tall the baby. The length that separate babies from those who are not premature. And it continues, it says, premature babies often require special care, and this result could be helpful to hospital administrations to planning for that care. If we know, if you ever seen them in the hospital, they're called incubators. Looks like a box, plastic box, a glass one, they put the baby in it, and special light and everything when the baby comes too early. If we know we get 10 per year or per month or per week, we better have 10 machines for them. If we don't plan accordingly and suddenly we get 20 of them, we only have 10 of these, what are we going to do? We're going to be scrambling, calling every hospital in the area, hey, we need to borrow yours, and they do that. You know. So let's see here, let's plan for them and get what percent, because if we know how many babies a hospital delivers per year, we can anticipate how many to have. So here it says a baby is premature if it's in the lowest 3%. So if you belong in this group, that's premature. That's the number that will decide if you are a premature baby or not. 3% of the babies born here are all of them actually below this number is premature, 3%. That means 97% of the babies are born not premature. So there's a positive side in case you decide to have a baby. Don't worry about that premature babies, only 3%. I need to work the problem backward. In this case, I know the size of this area. 3%. What does that mean? 0.0300. That's the size of it. 0.0300. So if I look at my table here, do I look at the positive z-score or negative z-score? Which one? Where is the line? Is it to the left of this point or to the right? To the left. That means negative z-score. Look for the closest number to 0.0300. 0300. I see 0301. You see that? That's negative 1.88. So the Z value is negative 1.88. Still, we're using the same number. We're using pregnancy as a normal distribution of what? 268 days. Standard deviation is what? 15. So Z equals X minus mu over sigma. Negative 1.88 equals X unknown, mu 268, sigma is 15. Solve it for X. $240 days. So any baby born before that 240-day period is considered premature baby. Need some help. If you're after that date, you're good. So 240 days is the cutoff. So the first time you go to the doctor, they try to pinpoint how long you've been pregnant. You know, we think you've been pregnant based on what describing to them. They can figure out the date. Your due date is this date. Remember, that could be off a couple of weeks, that due date. But now they can start counting from that date. You go, okay, you're now 60 days, you're 90 days pregnant, you're 100 days pregnant, 120, 140, 200, 220, 230, 240. Once you pass the 240, take a deep breath. It's not premature now. It might be too early still, but it's not premature. Now 250, 260. Once you hit the 260, you're golden basically. At 270, if it doesn't come out, go for a ride on a bumpy road and that baby will come out.